1 and 2-step linear inequalities. And inequality, remember, means it's not equal. So how do I solve 1 and 2-step linear inequalities? Well, solving inequalities, we're going to do a few things. We're going to solve and then graph. I'm going to come back to this box here for a moment, so I'm going to ignore that for now, because I'm going to go ahead and solve example 1 and 2. Well, this is just like an equation. Think of it as x minus 7 is equal to negative 1. Well, how would you solve that? How would you get your variable by itself or isolate the variable? Well, you're going to add 7, because whatever you do to one side, you need to the other. So we're going to have x is greater than negative 1 plus 7 is 6. Once you solve it, they're going to graph it. Notice this is a blank number line. So what I usually like to do is I like to just put what our solution is in the center. And then, depending on what it is, since it's whole number, I'm going to go ahead and just put a few on each side. Remember, the number line goes from least to greatest, going from left to right. So the other side needs to be numbers less than this target number, and then, or your solution, and your on the right is greater. So now it's x is greater than 6. So you're going to graph it. It's going to be an open circle, and it's going to be all the numbers greater than 6. That's kind of a crazy line. I don't know what happened there. So, because there's numbers in between 6 and 7. Don't start at 7 because there's 6.000002. So there is numbers all between 6 and 7. So you can't skip that whole number and saying it's starting at 7. Now this is multiplication. In order to get x or k by itself, you're going to divide by 6. And you're going to have k is greater than 15/6. Now, you can leave it as a fraction, but that's not simplified. So you want to simplify that. And 3 goes into both, so that's going to be 5 halves. And since we're talking about a number line, it's probably going to be easier. You don't go around and say, I have 5 halves of $1. You pretty much say, like, you have $2.50. So you can simplify this either to, k is greater than, it kind of looks like greater than 2.5. Since that's a terminating decimal, like that's a number that will turn into a terminating decimal, that's fine. And so now here's what I would do here. You could do 2.5 and count out by halves, or you can do whole number. You can do 2, 3, 4, here's a 1, here's a 0, and then you can plot it in between. You just have to be careful. We can't always assume. So when you plot this, you really should have the number 2.5. You can't ever just assume it's in the half. That's what drives me crazy, but a lot of people do it. Okay, so that's greater than. Okay, so now here we have division. We have y is divided by a negative 3 is less than or equal to negative 7. So in order to get rid of this denominator, negative 3, we need to multiply by negative 3 and both sides by negative 3. So we put y is less than or equal to, now negative 7 times negative 3 is a positive 21. Well, I'm going to do something real quick. I'm going to have you test a number. I didn't test up here, but I'm going to have you guys test something. What I'm going to do is I'm going to plug in a number that's less than less than 21, but I'm going to make it divisible by 3, so it's a little easier. So let's pick a number less than 21, but divisible by 3. So what comes to mind? 15, 18, 6, 12. So let's pick 15. If we put 15 back into the original equation, divided by negative 3 is less than or equal to negative 7. We're testing to see if that's a solution. So we're just picking a number less than 21 divided by negative 3 to see if that works. Well, 15 divided by negative 3 is a negative 5. And is negative 5, I'm going to put a question mark here, is negative 5 less than or equal to negative 7? No, this is false. So any number less than 21 won't work. So here's what happens. When you divide by negative 3 by a negative, or when you multiply by a negative, you need to reverse the sign. So when you multiply or divide by a negative, we need to reverse the sign. So now numbers greater than 21 or equal to 21 will work. So let's pick a number greater than 21 that's divisible by 24. So if we put in 24 divided by negative 3, keep that sign the same here in the original problem. Let's test it. Negative 24 divided by not negative 24. 24 divided by negative 3 is a negative 8. Less than or equal to negative 7. That's true. Okay, that's a true statement. So that means all the numbers need to be greater than 21. or equal to. So again, you're going to put 21, 22, 20. Like, you don't have to write every single number. Sometimes I like, about 3 to 5, of course. That's 19. Greater than 21 or equal to, so it's going to be closed circle, and it's all the numbers to the right. Now here, divide by -3. If we divide it by -3, when we divide by -3, we're going to reverse the sign. It's going to be a -6. So when you divide or multiply by a negative, you're going to flip the sign. So this is going to be -6. Now, careful here when you write your number lines. This is going lower. It's going in the negative, so this one looks like you go 6, 7, like -6, -7, -8. This will be -5, -4. So when you do negatives, make sure you're approaching 0 to the right. So greater than or less than -6, open circle, and less than. Okay? Now, back up here. This is why I waited. When you multiply or divide by a negative to both sides, you must always flip the sign. Okay? And the sign means when you divide, don't flip it until actually when you make that division or when you actually multiply. Then, once you do that computation, then flip it. Okay, so we're going to look at some examples. So we're going to solve these problems. And these are two-step inequalities. Just like two-step equations. How would you solve it? Well, this is saying 6 minus y is greater than 14. So we're going to go ahead and subtract 6 because that's being added. Don't look behind it. Look in front. That's a positive 6. So that's 0. Now, don't forget this negative. You have a negative y is greater than 14 minus 6 is 8. But we're not done. This is really saying a -1 times y. So we need to get rid of the -1 by dividing. When you divide, flip the sign. Now, if you're not for sure, test it. Pick a number less than -8, plug that in, and see if that is greater than 14. So, for example, if I test it, less than -8, let's try -9. 6 minus a -9, is that greater than 14? Well, 6 minus a -9 is 6 plus 9, which is 15, and that is greater than 14. So reverse the sign when you're dividing by negative. You could also solve it this way. 6 minus y is greater than 14. If you wanted to move the y this way, if you wanted to add the y, you would get 6 is greater than 14 plus y, and then subtract 14. You would have -8 is greater than y, and then reverse it. Y is less than -8. You could do that also. So you could move the y to make it positive this way, but as long as you move the 14 that way. Don't move everything the same side. That's what some of you guys are doing. So 3/5 k plus 1 is less than or equal to 13. Well, subtract 1. 3/5 k is less than or equal to 12. Now, you have multiplication here. Now remember how to get rid of the fraction. You want to multiply by its reciprocal. Multiply by 5/3. We don't flip the sign. We're not multiplying by a negative, so keep the sign. Now, this is saying 12 over 1 times 5/3. You can multiply straight across. That might be easy. Or go ahead and cross reduce. 3 goes into 3 once. 3 goes into 12 4 times. So 4 times 5 is 20. Okay. Now we have this. Negative f force plus 11 is less than -53. Subtract 11. Negative f. Well, it's like the whole fraction's negative. If one of the parts of the fraction's negative, it makes the whole thing negative. So just be careful there. So less than -53 minus 11. They're both negative. So you're going further negative, 64. Now, since there's a negative here, we want to get f by itself. So I'm going to actually multiply by -4. Multiply by -4. So then that way we get a positive f. But since I multiplied by a -4, because it's negative here, I'm going to reverse the sign. Negative times a negative is a positive. Now 64 times 4, 24, 25, 256. Okay, so you can work it out or grab a calculator, but sometimes it's faster to work it out. So f is greater than 256. Okay, make sure your line, sometimes I drop my equal sign, so I always go back and check. Now, on practice and stuff, you may or may not be graphing. Some of the times you'll be graphing. Okay, now this one, subtract 2, subtract 2. We have 3x is greater than or equal to -6. Now, divide by 3. divide by 3. Would we reverse the sign here? Okay, no, we're not dividing by a negative. Just because that's negative doesn't mean it's going to reverse the sign. So only when you're dividing or multiplying by a negative. So x is going to be greater than or equal to -2. With all this work, you might want to circle your answer. All right. So at this point, if you want to, you should have paused it along the way anyway, but if you want to stop it and work these and then come back and see if you have it correct, that would be great. Otherwise, I'm just going to keep going. So I'm going to subtract 22. -2x is less than 18 minus 22 is a -4. Divide by -2. You need to flip the sign. -4 divided by -2 is 2. Okay, now I hope if there's any errors, I don't know how you're going to let me know, but I'll figure it out. Okay, so there's that. So this is just like equations. This is why it's so important that you guys understood your equations and how to solve it. Okay, these are both negative. So a -42 divided by 7. Don't flip the sign because you're not dividing by a negative. Okay. This one, you're going to subtract 1 first. What is that? An x. X divided by -2 is greater than 3. All right, so multiply by -2. Multiply by -2. We do flip the sign. We reverse the sign. Reverse the sign. Okay, so then you subtract 2. -3/4 x is greater than 9. Now, again, the fraction. Don't change to a decimal. Now, this is a negative also, so you're going to multiply by a -4/3. Multiply by -4/3. Multiply by the reciprocal to get rid of that. This makes it 1. So x, now flip your sign because you multiplied by negative. 9 times 4 divided by 3, or you can divide first. 3 goes into 3 once, 3 goes into 9 3 times. 3 times a -4 is a -12. Okay? All right. Now, down here are the word problems. We're going to set them up. So sometimes you have to read it a couple times to see how this works. So the quotient of a number in -5 increased by 7 is at minimum 1. The quotient, so you need to know what this means. The quotient is an answer to a division problem. Okay, so a division problem. The only thing is when you write this, I do not want you to write the division sign. Don't write the division sign, use a fraction bar. So the quotient of a number, I usually like n or x is fine, but when it says a number, a lot of times I use n. The quotient of a number and -5. So write it with a fraction bar. Please do not do this. Okay, it's not, oops, -5. Okay, so that's a little harder to do. So you want, I would use a fraction bar. Increased by 7 is at minimum 1. So at minimum, so that means that has to be greater than or equal to 1. Okay, then you're going to solve. So subtract 7 divided by -5 is greater than or equal to -6. Multiply by -5. I'm running out of room here. Flip your sign. You're going to flip your sign, and n is going to be greater than or equal to 30. Okay, this one less than half a number is a maximum of 19. 1 less than half a number is maximum of 19. Okay, so you can do half of a number and 1 less than it. Maximum of 19 means it has to be less than or equal to 19. Think of it this way. I always put it in a scenario. Like if I can only have 19 people invited to a party. So I have maximum 19. That means I can have less than or equal to 19. So here's one way you can do this. Or that half a number, you could do this. N divided by 2 minus 1 is less than or equal to 19. So you could write your half either way. You can have it this way, or you can write it this way. So either way, you're going to add 1, and you're going to have half n is less than or equal to 20. And then you're going to multiply by 2, or 2 over 1, but you don't really need that 1 since that's what's happening. N divided by or equal to less than or equal to 40. So here, 40 would work. If you want to try it this way, that would work too. So you did not have to reverse the sign because there wasn't a negative that you're multiplying by. So your big thing with equations, with your inequalities, is solving it just like an equation. Do all your steps like an equation. The only difference is when you multiply or divide by a negative.